And here we are with part 4 of our series in predicting reaction types of these 5 reactions: SN1, SN2, E1, E2, and neighboring group participation, which we haven't talked about yet. We will remedy that situation right now. Won't you be my neighboring group participation? NGP. Finally. Here we go. Always looking at the carbon with the leaving group first. Secondary could be SN1, SN2. There's something unique about this molecule. Phosphorus has a lone pair. Lone pair like other nucleophiles. But this time our nucleophile is in the same molecule as our leaving group. This is the story of neighboring group participation. When you have that combination, it is our second type of override. And you get neighboring group participation. Same scenario down here. Secondary, we don't know. SN1, SN2. In fact, I just noticed the first one is tertiary. Going back? I should learn how to count a little more carefully. Carbon with the leaving group has a methyl up top, an ethyl to the right, and a big group to the left. 3 carbons, tertiary. Normally thinking SN1, but we've established there's an override. Nucleophile next. Never skip these steps, please. You get 3 points for the analyses and 1 point for your conclusion. For 4 points every time you leave a blank, you get a blank score. Ethylamine is this species here. It is a moderate nucleophile in the mean category. SN1 or SN2, we don't know. We've already made our decision, but we continue our analyses always. Isopropanol down here is a poor nucleophile. All neutral oxygens are poor nucleophiles. That's an SN1 candidate, but we've already made our decision based on the same overriding feature here. We have a selenium nucleophile in the same molecule. Selenium is in the sulfur and oxygen column on the periodic table. All of those are nucleophiles. Phosphorus is in the nitrogen column. All nucleophiles. Selenium's nucleophile will be used during the reaction mechanism. Not really called for, but almost mandatory for figuring out the products. Okay, we had an override leading to NGP. And solvent. No solvent listed. No solvent listed. Solvent is also the nucleophile. In my previous video, I mentioned this is quite common. If the solvent was participating, we would call this solvolysis, a common reaction type. Could be SN1, SN2, NGP even. So here we go. What happens during NGP? The lone pair on the phosphorus does a backside attack on the carbon with the leaving group. Backside attack is going to flip this stereocenter. We'll figure out R and S in a second. Leaving group leaves. Same story here. Little curvy there. Backside attack. Leaving group does what leaving groups do. It leaves. We're going to have to draw the full leaving group. If you want to do that right now, why not? Leaving group is here. That is the perchlorate ion. If you condensed it down, it would be ClO4 negative. And that looks like this structure right here with a full Lewis. And it's conjugate base of perchloric acid. Conjugate base of any strong acid, excellent leaving group. We're going to look at the intermediates created here and here. They're going to be cyclic. In this one, the cycle will have 4 atoms in it. Phosphorus for 1, carbon for 2, another carbon for 3, and this third carbon for 4. Over here it'll be a triangle. Selenium for 1, carbon for 2, and this other carbon for 3 in a triangle. Let's draw our square and our triangle. Over here we have our square. And down here we have our triangle. Question for you: why is this new bond to phosphorus on a wedge? The simple answer is we did a backside attack on a carbon whose leaving group was on a dashed bond. The backside of the dash is a wedge. So the stereocenter got flipped, inverted. Same story down here. Why is the new bond to selenium on a dash? Well, we're coming in 180 degrees from a wedge bond. That is a dash. The stereocenter got inverted. Let's put R's and S's down just to verify that. We started with an R stereocenter and we generated an S stereocenter when we did this step here. And when we did this step here, we generated an R stereocenter. Backside attack flips a stereocenter. Now the question is, when we pop open our square or our triangle, which of the two carbons, this one or this one, there or there, gets attacked? And the answer is this carbon here, because it's less hindered. This is not the same as we learned with our first backside attack on a triangle. These triangles behave differently. They're not as unstable as our halogen triangles in Chapter 6. Those were all dependent on carbocation stability. These get attacked based on steric hindrance. The carbon that's easier to get to is this one right here. It doesn't have 3 carbons attached to it. This one here, there's 3 carbons attached. Backside is more blocked. Up here, we're going to be going for this carbon. That's not even where the leaving group was, because this one is tertiary and this one's secondary. So I'm going to put our nucleophile down here attacking this carbon, and I'm going to put my nucleophile down here attacking this carbon, and I'll be right back. Here we go. Backside attack on the least hindered carbon is going to create our final product. And on this one, backside attack on our least hindered carbon is going to create an oxonium. An oxonium is never a final product because you're not allowed to finish any reactions with strong acids. An ammonium is not a strong acid. That's going to be the first product up here. And a oxonium is a strong acid. So you can't stop there. I will draw our 2 products. So our nitrogen did a backside attack on an R stereocenter and created a new S stereocenter with an ammonium attached. Our oxygen is doing a backside attack on an R stereocenter, and it flips again back to S. And because it was this carbon that was attacked both times in this mechanism, S was the start, R was the intermediate, and S was the end. 2 backside attacks on the same carbon. In our first one, we had an S stereocenter here that didn't participate at first. The R was flipped in the NGP step. The NGP step S stays S because it doesn't get attacked again. The less hindered carbon got attacked. That's where we had a flip of this stereocenter. So NGP has some interesting things going on. And I think this brings to an end our discussion of neighboring group participation. Once again, these questions aren't really asking about mechanisms, so this is not part of the story. Whoa, we got rid of a lot there. Don't want to lose my box. I hope you found this video to be useful, and I look forward to our next video.